Bismillahirrahmanirrahim. Good morning. Today we explain seminar number 14 in dental implant, CAD technology in implant dentistry. The first part of this seminar submitted by postgraduate student in prosthodontic Zahraa Noori Yassen, College of Health and Medical Technology, supervised by Assistant Prof. Dr. Sajaa Ali Mohsen. At first, we take introduction about this subject. The CAD technology represents a major revolution within the modern dentistry. It is now possible to generate a virtual model from the direct digital scanning from the mouth, models or even impression, enable the designing and manufacture of the structure by computer assistance. With this technology, it is possible to manufacture structure for implants, bridge, custom abutments, bar, copings, surgical guides, and everything that can be developed in the software. CAD offers level of quality and accuracy by any of the traditional technique. Benefit of the framework for a long span restoration is much easier to achieve and reproduce with CAD than with the traditional puring technique. The use of CAD machining for implant-supported restoration, a highly accurate and predictable framework fit. In addition, machining centers can reproduce restoration using fully biocompatible materials such as titanium and zirconia. Okay, now we have CAD components. CAD systems are composed of three major parts: a data acquisition unit and software and computerized milling device. In this slide, we shown this image of first component of CAD system, data acquisition unit, which collects the data from the area of preparation, adjacent and opposing structure, and then converts them to virtual impression through intraoral scanners or indirectly by means of a stone model generated through making a conventional impression. Okay, now we have two images in this slide of the second part of CAD component. The second part is software for designing virtual restoration on a virtual working cast and then computing the milling parameters. Many software already comes with data libraries with the setting of the many different implants, favoring the adaptation of the manufactured components. The scan data is converted into format that allows the three-dimension image to be utilized by the selected treatment planning software. Then planned in the software, if computer settings are correct, is ensured of perfect reproducibility in the manufacture process and consistency in the result. We reached the third part of the CAD component, a computerized milling device for manufacturing the restoration from a solid block of restorative material or additive manufacturing. This is the last phase of the dental CAD process. It involves developing a restoration from a CAD model into a physical part that undergoes processing, finishing and polishing before being inserted into the patient's mouth. Now we discuss the general classification of CAD system. CAD system is classified generally into two types: laboratory system and chairside system. This image represents the laboratory system, which is further classified into laboratory CAD in which the company has its own scanner and milling units, and CAD computer-aided design system in which the company has only the scanner, and CAM computer-aided manufacture system in which the company retains the milling machines unit. This system has several advantages: automated steps or all of fixed restorative fabrication and highly accuracy, and less chance for error compared to traditional technique. Scanned image transfer directly to the laboratory from the office and reduce chair-side time, also team approach to fixed restoration. Okay, this image represents the second type of cut-gum system, the chair-side. The chair-side cut-gum system is further classified into chair-side cut-gum, in which the company has its own scanner and milling units, and image acquisition system, in which the company has only a scanner without designing capabilities. These in turn must be connected to the unopened laboratory scanner for designing of the restoration. This system has several advantages and disadvantages. At first, advantage of chair-side system: one visit fixed restorative procedure and no impression making, no temporary restoration required, and reduced potential for tooth sensitization, no laboratory course and model or dye puring, less chance for error compared to traditional technique, and project a state-of-the-art image. Disadvantage of chair-side system: soft tissue mini-image, more critical than with the traditional technique and depending on material and patient. High learning curve and high production required to cover capital investment. Okay, now in this slide we have a classification of scanners. Scanner classified into two types: chair-side scanner and laboratory scanner. Chair-side scanner, the intraoral camera, are optical scanner and can be separated into two types: image camera and video camera. Image camera, which may be single that records individual image of dentition, and 3-shape that records about 3 teeth in a single image. To record large area of dentition, series of overlapping individual images are recorded such that software program can assemble these into larger three-dimensional virtual model. Video camera, which are used by the true definition scanner. The camera is positioned in different angles to ensure accurate recording of data below the height of contour that would be hidden from the camera if only occlusal view was obtained. Laboratory scanners are classified into optical scanner and mechanical scanners. These two images represent the two types of laboratory scanner. The image in the right aspect called mechanical scanners, in which with the scanner is capable of reading a master cast mechanically line by means of rapid pull in order to obtain three-dimension measurement, while the image in the left aspect called optical scanner, which use the projection of the measuring light guide onto dental structure under a defined angle. This slide contains an image of design software. We're talking about it now. Design software: special software is provided by the manufacturing for the design of various kinds of dental restoration. With different software from different manufacturers, various designs can be implemented, such as copings and fixed partial denture frameworks and full anatomical crowns, inlay, onlays, and veneers. However, the general forms of tooth morphology provided by this cut-gum system can provide only basic shapes. There is always some manual alteration and modification required because every patient is unique and every tooth has its own morphological features that are unique for the patient system. Okay, now we're talking about subtractive technology milling. This image in this slide represents it. Subtractive technology milling is the one primary method used to fabricate the restoration in digital process. Subtractive milling and grinding that use a wide range of machines to efficiently present cut a variety of material, such as metal and plastic, into a defined geometrical part. Milling machines rapidly produce end-use parts. It is available for all types of materials, but this milling have several disadvantages. The thinnest part of the restoration is limited by the size of the part. If the thinnest part is smaller than the smallest part, it will result in over-milling and cause loss fit restoration. Also, it's expensive for using glass ceramic blocks and require expensive CAM units. Okay, now we have some images in this slide which explain the veneering technique and digital process. The cut-on veneering technique is become more popular because of absence of voids or defects and ensure uneven thickness of the veneer porcelain. Also, less number of rings and lower coefficient of thermal expansion than brass and layer porcelain, resistance to aging, and higher bond strength between the veneering ceramic and zirconia as compared to layering and bracing technique. Veneering technique classified into three methods: traditional and bracing and cut technique. Bracing technique contains milling wax or bearing out resin and manual wax up and 3D printing of parent resin. Cut technique contains milling of zirconia coping framework and lithium disilicate veneers porcelain at this same time. Attachment of the two parts by either cementation or fusing glass. Okay, now we finished the first part in seminar number 14 in dental implant. We get many information about classification and components of CAD/CAM technology. We reached the second part, which will discuss by the postgraduate student Zahraa Noori Yassen. Now, thank you very much for your listening.